Hi, this is Reese, and in this video, we're going to try and connect like all the different derivative levels here. So the F prime and the F double prime. And we're going to focus primarily on graphs. So I have a quick little thing here for you that if you're looking at graphs, remember that if you're given just the F graph, check slope for F prime, and for F double prime, we check curvature. So look for like an upward or downward concavity. So for instance, here, this is the one graph, by the way, I'll be referring to throughout. Try to estimate where F prime and F double prime are zero, positive, or negative. So we'll start off with F prime here. So again, with F prime, we want to check the slope, because remember the derivative is the slope. So you'll notice that the slope of this curve is negative in this interval, and we'll assume, by the way, that the interval goes from -4 to 4. So it's down until you hit -2, and then it's up until we get to 0, down until we get to 3, and then up when it's 4. So hopefully that kind of illustrates, where F prime is in its value. So F prime for this is negative in the interval -4 to -2, and it's also negative from 0 to 3. On the other hand, it's going to be positive in the other intervals, so -2 to 0, and from 3 to 4. And you'll notice that if you combine all these together, you get the entire domain of this function, with the exception of the turning points. So that's where the derivative, by the way, would equal 0. So it equals at x equals -2, at x equals 0, and x equals 3. Now, a word of note that we do not have any like sharp turns. This is all totally differentiable. So it's not like bam and then like this, because then the derivative would not exist here and you wouldn't include it right there at -2. Okay, so what about part B, the curvature? So F double prime, remember we want to check for up or down. So concave boy is pretty happy. It's positive when we're concave up and negative if we're down. So for F double prime being less than 0, you should see that it's like basically right here. And so for that portion right there from -1 to 2, and where it's positive is in the other two parts. Like you can see it on the right here and also on the left there. So therefore, greater than 0 in those two intervals. And just like what we said before, like if you combine this together, you should get the entire domain. So that definitely is the case. Now here, F double prime, hopefully you can get where it's 0, definitely is going to be 0 right where the changes occur. So therefore, at x equals -1 and at x equals 2. I thought I'd make a mention that if you get a situation where the graph is doing this, like it does here, but instead of bending downward, like it may bend downward more severely, so you get like a cusp. So there the derivative does not equal 0. It in fact does not exist. But even though it doesn't exist, you would still say this is concave up, concave down. And you would be able to record these nonetheless. And it would all be considered an inflection point. So with that stated, let's look at it like this now. Let's assume that the graph is now f prime. All right. So instead of f, we have f prime. Determine where f double prime is going to be 0, positive, and negative. So if that's the case, it's a little different because here with f prime, remember that f prime is the slope, right? It is the slope of f. And therefore, if you're talking about f double prime, well, f double prime is the slope of f prime. So if this is the graph of f prime, then for us, we're looking at this, 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 this. All right. So where is f double prime 0, positive and negative? Just look at the slopes. And you'll see that what we had a moment ago kind of follows here in the same way, just a different context. So f double prime is less than 0, where -4 to -2, and also from 0 to 3. And it's greater than 0 from -2 to 0, and from 3 to 4. So where is f double prime equal to 0? Notice the special points here. It would be at the extrema. So therefore, when you look at the first derivative graph, look for the extrema. That's going to be important for us. So at x equals -2, at 0, and at 3. And I want to make a note that, again, even though our graph is nice and smooth here, that if it was a sharp corner here, this would still be considered an inflection point because it is an extrema. It is a place where the slope suddenly changes from negative to positive. And that's what you're looking for with inflection points. That is, where's the sign change? Okay, well, what about f? Determine the extrema of f and where f is increasing and decreasing. So in this particular case, again, this is still the graph of f prime. How do we get the extrema of f, where they occur, and where f is increasing? So going back, remember that f prime is the derivative of f by definition, and the derivative is slope. Which means that for us, if we want to know where f prime, where f is increasing, then we want to know where f prime is positive. And f prime is positive everywhere where it's above the graph, the axis there. So you can see that it's above the axis throughout until you hit 1, because it's at 1 where it finally crosses over. So what do we put? Well, we say that it's increasing from -4 to 1. And oh, by the way, on a test, you don't say it. So f increases because you're talking about f prime versus f. So just remember the context of this. F increases in that space. And then where is f decreasing? So it's decreasing where it's below the axis, right there. So from +1 to 4. And where you cross will tell us the extremum. So for us, the extremum is located at 1. And hopefully you can tell what kind. In that at 1, it goes from positive to negative, which means that the slope was positive and then it went down to negative, which means that that is a maximum. One other thing to consider is that when you look at this, think about it as this whole thing here was positive. So it's like right there. This whole thing here was negative. So it's like right there. And when you kind of piece it all together here, right there at 1, right here at 4, and such, you take it all by itself, and you'll notice that you just kind of have like a sign chart. And so with the sign chart, you can see right here increasing and decreasing. Okay, that does it for this. You got any questions, let me know. Otherwise, I'll see you next time.